Welcome to the video lecture series on principles of compiler design. In today's video lecture, we'll be learning about input buffering, the mechanisms which is used in lexical analysis. Now, before stepping inside what is input buffering, you will know what is meant by buffer. Buffer is called as a temporary storage memory, where it is actually used as a part of RAM. It can actually store a data only for a short duration of time, and after that it will get erased. So the memory which is stored or data which is stored inside this buffer is volatile, and since it's a temporary memory which it has only a limited amount of space. Now we will step inside what is meant by input buffering. So input buffering is a mechanism which is used in lexical analysis to form the tokens. Now, this input buffering has two pointers. One is called as a lexeme beginning pointer and another is called as a forward pointer. So, the lexeme beginning pointer points to the beginning character of the current lexeme, and the forward pointer reads every character one by one till to the end of the lexeme. Now, this forward pointer and the lexeme beginning pointer is used to identify the beginning and the end of the lexeme. Now, there are two types of buffering. One is the one buffer scheme, another is called as a two buffer scheme. Now, in this one buffer scheme, the forward pointer advances from the beginning of the lexeme to the end of the lexeme, and it verifies whether the lexeme has an entry in the symbol table or not. If it does not have the entry, then the corresponding entry will be made in the symbol table, and next the beginning pointer will be moving to the next lexeme. So from the beginning pointer to one step before the forward pointer is considered to be the lexeme here. Now we will have an illustration of how a lexeme is identified and how the entry is actually made in the symbol table. All this concerning details will be explained here in an elaborate fashion. Let us assume that we have a high level instruction sum equal to a plus b, and this high level instruction has an entry inside the buffer. Now both the forward pointer, FP is called as a forward pointer, LB is called as a lexeme beginning pointer. Both will be pointing to the beginning of the lexeme. Now when we go further, forward pointer moves one step ahead and it points to U now. Now U is also part of the lexeme. U is also part of the first lexeme. Now once again forward pointer advances to the next one. Now it goes to M. Now M is also called as a part of the lexeme, first lexeme. Now forward pointer goes to the next one. Now you can see equal to is called as a new lexeme, whereas sum is called as the previous lexeme. Now from lexeme beginning pointer to one step back of the forward pointer, that is up to M, is considered as a lexeme here, first lexeme. Now sum is verified in the symbol table. The entry has not been made in the symbol table, so the entry will be made in the symbol table like this. You can see that sum is called as is mentioned, and then location, the memory location of the sum is mentioned here. Since sum is called as the first identifier, ID1 is given. Now the corresponding token will be generated as identifier and number is given as 1, since it is mentioned as ID1 here. This is called as a first lexeme. Now lexeme beginning pointer will be moving to the beginning of the next lexeme. Next lexeme is called as equal to. Now forward pointer will be moving to the next item. Now what happens is A is called as a new lexeme, and this is not part of the previous lexeme called as equal to. Equal to and A are two different lexemes. So equal to will be considered as a new lexeme now, and it is verified. Since equal to is called as an assignment operator, corresponding token will be made here. Now lexeme beginning pointer moves to A now. Now forward pointer will be moving to the next lexeme, next location. Now plus is not part of A, because plus is a different lexeme and A is a different lexeme. Now A will be verified in the symbol table. A lexeme is not been made as an entry in symbol table. So what happens is A will be made as an entry in the symbol table and the corresponding location 1700 will be given. Since A is the second identifier, a token will be generated as ID2. Now, lexeme beginning pointer will be moving to plus. Now, forward pointer will be moving to the next location. Next location is B. Now, B is not actually part of the lexeme called as plus. So, now plus is called as a arithmetic operator. So, add operator token will be created. Now, lexeme beginning pointer will be moving to B. And now, forward pointer will be moving to the next location. Now, semicolon is not actually the part of B lexeme. So, B lexeme will be searched in the symbol table whether entry has been made. But since entry has not been made, B entry will be made in the symbol table and its location is given as 2800. All these locations are actually called as hypothetical nuclear locations. For simplicity, we have given the locations like this. In real time, the locations will be much more complicated. It will be given in a hexadecimal form. Now, lexeme beginning ID3 token will be generated. Now, lexeme beginning will be moving to the next lexeme called as equals semicolon. Now, forward pointer will be moving to the next location. Since next location does not have anything and semicolon is considered to be a lexeme now. So, semicolon special operator token will be generated. So, this is how actually input buffer scheme, one buffer input scheme, buffer scheme is actually working. Now, we'll go to the next one. The next one is called as a two buffer scheme. So, this is an algorithm for a two buffer scheme. Now, the buffer itself is actually split into two portions, the first half and the second half. So, if the forward pointer moves to the end of the first half, that is first half EOF, if it moves to the end of the first half, then forward pointer will be moved to the second half beginning and second half will be loaded. And similarly, if forward pointer is actually to the end of the second half, then forward pointer will be moving to the first half beginning and first half will be loaded. So this is how actually the algorithm is actually functions here. Now let us take three statements here: x is equal to a equal to b, and b equal to x. Now we have to execute these three statements inside this two buffer scheme. Now the first statement, x is equal to a, is actually loaded in the first half. So in the left side you have a color and the right side you have another color. The left side color is actually the first half and the right side color in the buffer is called as the second half. So for distinction we have made like this. Now in the first half, x is equal to a is loaded and you have a semicolon, and after that you have an end of file marker. Now what happens is forward pointer and lexeme beginning pointer will be moved, beginning of the lexeme pointer. Now forward pointer will be moving one step ahead, now equal to. So equal to is called as a different lexeme. So x is called as the first lexeme. Now x will be created a token, ID1 will be created. Now beginning pointer will be moving to the next lexeme. When it moves to the next lexeme, now we will advance forward pointer one step. Now when we advance forward pointer one step, you can see a is a different lexeme and it is not connected with equal to. Equal to is a different lexeme. Now equal to is an assignment operator, so the token is getting created. Now beginning pointer will be moving to a now. Now we will advance forward pointer one step ahead. When we advance forward pointer one step ahead, you can see that semicolon is not part of a, because a is a different lexeme and semicolon is a different lexeme. Now a is an identifier too, that token will be created, and now beginning pointer will be moving to semicolon. Now what happens is we will move the forward pointer one step ahead. Now forward pointer goes to EOF, this is called as the end of the file. Now what happens is this semicolon is called as a special operator, that token will be created. Now since we are in the end of the file, the algorithm says when forward pointer is at the end of the first half, then it should move to the beginning of the second half, then the second half should be loaded with the second statement. Now what happens is it moves to the beginning of the second half and then the second half is loaded with a equal to b semicolon EOF, because that is the second statement. Now beginning pointer will be moving to the second half now. A. Now we advance forward pointer one step ahead. So equal to is called as a different lexeme. Now A already A identifier lexeme is already there. Token is already made. Now equal to, it points to equal to. Now forward pointer is moving one step ahead of equal to. Now you see B. Now equal to is a lexeme now. B is not connected with equal to, so assignment operator is here. Now beginning pointer will be moving to B here. Now advance forward pointer one step ahead. Now you can see that B is not connected with semicolon because this B and semicolon are two different lexemes. Now since B is a new token, so it will be created as ID3. Now beginning pointer will be moving to semicolon. Now we advance forward pointer one step ahead. Now forward pointer goes to EOF. Once it goes to EOF, now semicolon points to a special operator. Once it goes to EOF, what happens is automatically the first half should be loaded because the forward pointer is at the end of the second half. So now you can see that the third statement is getting loaded on the first half. That B is equal to X is getting loaded in the first half. Now forward pointer will be moving to the beginning of that. Now beginning pointer will be moving to the beginning of it. So that's how it actually functions. Two buffer scheme will be functioning like this. Thanks for watching the video. Have a good day.